Oh my God, it started.
So you're real life.
Yeah, perfect. Perfect, Anastasiya. Good, good. And welcome, everybody. This is AWS user group meeting, the Krakow chapter. We are streaming directly from California. No, I'm just kidding. Come on. We're streaming from, actually, I think it's now globally available. So we're starting today our second meeting online. I think the third meeting this year. We have one more in backlog that will start maybe in 1 month or two. But today, everybody, we welcome you from the Schibsted with support from them and thanks them very much. Anastasiya, will tell a little bit more about our partner this time, but thank you very much that you are here. I know that evening after entire day of telcos, it's a lot, it's a huge sacrifice from yourself that you are here. But to be honest, amazing stuff's gonna happen. Anastasiya, the stage is yours. Thank you very much for supporting AWS user group.
All right. So I don't want to bore you guys, so I will tell you a few words about Schibsted. Actually, Schibsted Tech Polska is a part of Schibsted, which evolved from a small printing house and became a huge media company that is a house of digital brands available in media, marketplaces, and next areas. And actually in Krakow and in Gdańsk, we have our Polish offices where we develop software together with our colleagues from Norway and Sweden. We are more than 200 people right now, and we are happily supporting initiatives like that. So I'm really happy to welcome you today. And I hope that you enjoy our event. We have prepared pizza vouchers for you. So there is a form in the link below, right? It will be also posted on the YouTube chat. So you can go there, you can fill out the form, and you will get a voucher for pizza. So let's hope it will remind you a bit our usual events at the offices.
Good, good. Remember to be quick, guys, because the first in, first out. Remember that the pizza places there in Krakow, we have like 3, it's a small city. So you need to be fast. Otherwise, you will get the pizza in like 4 hours. So keep it up. Okay, Anastasiya, you tell a little bit about Schibsted. Tell me a little bit more. What you doing, guys? What you seeking from the technology? Why you having us here? Why the AWS user group? There's so many user groups out there.
Well, that is a technology that we work a lot. And actually, tonight you can get an advanced notice of a new role that we will have open at Schibsted. This is so new that you will not yet find it even on our job page. So you can reach out to us directly. And it will be a very high-level engineer who will take care of the whole infrastructure of all of one of our brands in Sweden. So it could be an exciting role. So that's one of the reasons, but of course it's not the only one. We just love AWS here.
All right, perfect. It's good. It's great, guys. So if anybody wants to switch role, for I think a big guy, big mama architect. So let's do it with Schibsted. They will tell a little bit today about technology that they're using from the AWS warehouse. So I think, Anastasiya, what you think? We should go for the first presenter, I think, because it's evening. Everybody will order pizza right now, and they will like with one eye looking, oh, this is the guy. But guys, remember, Filip. It's going to be another next person is going to be Filip Golonka, and he will tell about Lambda at Edge, which is kind of super interesting with Terraform. So it's going to be a big thing. Filip, are you here? Are you with us?
Yeah, so one thing that I wanted to remind you is actually if you want to ask any questions about this presentation, you can post them on YouTube chat and we will be able to answer all of them after the presentation. So
that's right.
We are ready to start then.
Yeah, that's right. And Filip will, you are ready? Tell me something.
Yes, I'm ready.
Hear you very well, man.
Yeah.
Okay, we will after that. You can post the questions right now during the presentation to not get, to not lose them. And after that, I will go and read and find out. We'll put it on the screen. The questions which we'll go through. So, Filip, the stage is yours. We are shutting up.
Great. So hello, everyone. Thanks for joining this event. Today, I would like to tell you a little bit about Lambda at Edge, which is, as Maciej mentioned, super exciting. But this is backed by Terraform. Why Terraform and not CloudFormation? Well, basically, in our company, we are using different cloud providers, and CloudFormation, in our case, isn't that flexible. So we need to have basically one tool for doing infrastructure as a code. And in our case, we decided to use Terraform. So this presentation will consist of 4 parts. I would like to be as practical as possible. So even though there is a part called, which name is History and Theory, don't expect it to be too long because it might be too boring, and especially that you're after your working hours. So expect like some examples on AWS, some Terraform code, and some use cases from the practical life. A little bit about myself. My name is Filip Golonka. I'm working as DevOps at Schibsted Tech Polska. I'm here from 6 years. Previously, I was working as software engineer, then engineering manager twice, then also tech lead. So I know the business from different sides. And finally, I landed as a DevOps from 6 months. So this is yet another experience for me. Here you have my Twitter account and also my GitHub login. All the code examples will be available as repository on GitHub, so you can follow it up there. So let's talk about history and theory of Lambda and Lambda at Edge. So AWS Lambda was announced in 2014. And when it was announced, it was like game changer. You may spot some bad opinions about Lambda, but this is because there was a period of time when there were like super hype for AWS Lambda, and very often it was misused. So people like had some problems, some big problems, which came from not from fact that Lambda is working as it is, but from fact that the architecture was chosen incorrectly. So this was introduced in 2014 during AWS reInvent conference, and Dr. Werner Vogels, AWS CTO, said that the focus here is on the events. Events might be driven by web services that would trigger these events. You will write some code, say, in JavaScript, and this will run without any hardware that you have to provision for it. So quite a big change of the approach we know then. So initially, it was only possible to write the code in JavaScript. So there was like the only runtime allowed in Lambda was JavaScript. In 2015, AWS added the runtimes for Java and for Python. 2016 and 2017 was more like scaling years. So initially, Lambda was available only in some AWS regions, and later they were scaling it to be available in more regions. Also in 2016, there was support added for .NET, in 2017 for Go, and finally in 2018, again, during AWS reInvent conference, it was announced that besides the runtimes that are already available for Lambda, there will be like one new generic runtime which allows you to write the code in basically any language you want. So you can write in Ruby, PHP, Erlang, probably Rust as well. So on top of Lambda and on top of CloudFront, there was the service called Lambda at Edge designed. The preview was launched in 2016, so it was available for some people, and then it was like widely opened in July 2017. So when it was announced, there was a blog post from Jeff Barr, chief evangelist at AWS, which says Lambda at Edge allows you to create web-based user experiences that are rich and personal. As it's rapidly becoming the norm in today's world, you don't need to provision or manage any servers. Yeah, so what you can do here, you can basically inspect cookies and rewrite URLs to perform A/B testing. You can send specific objects to your user based on the user agent header. You can implement access control by looking for specific headers before passing the request to the origin. You can add, drop, or modify headers. You can generate new HTTP responses without even bothering your origin. You can cleanly support legacy URLs in your applications, which might be a bit challenging. You can modify or condense headers to improve cache utilization, or you can make even HTTP requests to other parts of the internet in order to generate a response. So let's talk briefly about the concepts behind Lambda at Edge. So yeah, we know that we need Lambda. So this is basically the piece of code you would like to execute. In order to have this Lambda at Edge, you have to actually have the Edge. So you need CloudFront distribution. You need a little bit of IAM magic to basically, glue these things together. And you need something called trigger or event. I will cover this a little bit later. So basically, Lambda at Edge is one combination of CloudFront distribution, cache behavior, and event that causes a function to execute. So you can basically use one of your lambdas for like different triggers, but you have to remember that to one CloudFront caching behavior, you can assign just one event. So in the other words, you can just assign one Lambda function to the viewer request, and you cannot define lambdas for twice for two viewer request events. So once you will have all these things together, and you will decide which trigger is like sufficient for your Lambda function, what will happen? Your Lambda will be deployed to each of the AWS point of presence. Right now, it means that your code will land in over 200 locations all around the world. So this is the answer why it might take some time in order to deploy CloudFront together with Lambda at Edge, because it needs to be propagated around the world. But it's even worse. If you would like to delete the function, it's like immediate to delete it from the CloudFront distribution. But when it comes to deleting the Lambda itself, it might be not allowed during a couple of hours, because there might be still some references left in some point of presence of AWS. So going back to the trigger or to the event, we have 4 types of triggers. So basically, first of all, we have viewer request. Once user is requesting something, before CloudFront will start actually doing its magic, the viewer request event is fired. So if you will generate some sort of response in this event, of course, CloudFront will not start looking up in the cache. It will not pass the request to the origin server. This will generate the response, return it to the user, but this response won't be cached. So you have to remember about this. The second event is origin request, and it is fired only on cache miss. So if CloudFront will find out that it has the cached response, then this response will be sent back to the end user, and origin request event will not be triggered. If this trigger, this origin request trigger, if it creates some sort of response, then HTTP request is not sent to origin server, and instead this response is cached inside the CloudFront cache and then sent to the end user. So the next user that will come with similar request will be served from cache. The third trigger here is origin response. So it is again fired only on cache miss, but after the request was actually sent to the origin server. So you can basically generate some sort of response here, or modify the existing response that is served from the origin server. And then after this event is done, CloudFront will determine if this response is cacheable or not. It will store it in the cache, so it will be then available for the next user that is coming with similar request. And the last available event is viewer response, and this fires immediately before response is returned to the viewer, no matter if this is cache or if this is hit or miss. And any modifications that are made to the response object are not stored in the cache. Right. So the first part is over. So no more boring theory. Let's take a look into the actual examples. So here you can see my AWS console. So I have already created the CloudFront distribution. It has 3 origins added. I have some caching behaviors. So let's take a look into the second one, for example. So I would like, in this caching behavior, I would like that this will serve all the requests that starts from the podcast string. The origin I would like to use is podcast backend. I would like to redirect all the HTTP incoming requests to HTTPS. I allow basically all the HTTP methods that are available in CloudFront, and I would like to cache all the HTTP methods that are available here. I'm using origin cache headers, of course. And as you can see at the end, in the Lambda function association, I have two Lambda functions associated. So to the event called origin request, I would like to assign the function called routing and the version number 6. So let's take a look into the Lambda configuration. While CloudFront is global service, Lambda is like couply tied with particular region. So make sure that in order to use Lambda at Edge, all your Lambda functions are created in North Virginia, because otherwise you won't be able to associate your Lambda function to your CloudFront distribution. Let's take a look into this function. Yeah, so I have my JavaScript code here. I'm retrieving a request object from the event. If URL starts with podcasts, then I would like to basically replace this podcast in the beginning to just slash. And the same if URL starts with notifications. Other than that, I'm logging the request URL before replacing and after replacing. And at the end, I'm calling the callback, which is passed as an argument to this Lambda function. And the second argument is request. As this function is assigned to origin request event, calling this callback will cause that the request will be sent to the origin. If I will scroll to the top, I can see that I have my Lambda function here, but in the designer, I don't see that it's triggered. Why? Basically, the latest version of your Lambda will not display those triggers. So if you would like to see them, you have to switch to the latest published version. So here I can see that I have my Lambda function in version number 6, and I have 3 CloudFront triggers. So I can see that all of them are coming from the same CloudFront distribution. And for example, I have the trigger for the path pattern, which is starting from podcasts, and event type is origin request. Good. In the permissions tab, I can see that my Lambda function is allowed to create log group, create log stream, and put log events in CloudWatch logs. So basically, all the console logs that I have in my code will end up being stored in CloudWatch. So let's test it. So I'm requesting my CloudFront address /podcast, and I can see that I'm getting the response. This is basically the response from this backend, so nothing so fancy here. And in the response headers, there is this XAMZ CFPOP response header, which is saying that I'm served by Frankfurt location. So it would be great to actually see the logs for this. So let's go into CloudWatch. Yeah. So as you can see, I have my log group opened, and there is 0 log streams. Why? As I mentioned before, once you are assigning your Lambda to CloudFront distribution, it is deployed across different point of presence. And for example, I'm served by Frankfurt point of presence right now. So all the logs will be stored in the AWS region, which is the closest to this point of presence. So in fact, this is EU West 1, Central 1, which is Frankfurt. So switching to Frankfurt. And I can see that there are some log groups here. So I'm selecting this US East 1. And I'm able to see that my URL before replace was /podcast, and after replace it was just /. And also some information from Lambda about duration and stuff like this. Good. So I would say it's time to take a look into the code. I added those QR codes here, so feel free to scan them. I'm not sure if this will work properly or not, but let's at least try. Also, you can find this code on my GitHub account. So I decided to write some code in Terraform. So let's start with main TF file. First of all, I would like to determine the Terraform version which I would like to use. Then I'm basically declaring that I would like to use AWS provider for Terraform, and I would like to do all the stuff in US East 1 region, which is North Virginia, which is basically required for Lambda Edge to work. I would like to use also the provider called Archive, and I'm defining here IAM policy for Lambda logging. So this is basically something you were able to see in the AWS demo. So I put there, I show there that my Lambda functions has the access to create log group, log stream, and put log events. So let's take a look into my routing Lambda. First of all, I would like to create the archive with my source code. So I would like to create zip file from the file which is in this location, so src lambda routing index.js, and I would like to store this archive in dist/routing.zip. Then I'm declaring my Lambda function. So I would like to use the file, which is basically the output from this archive, so dist/routing.zip. I would like to use also the hash, and I would like to send it to AWS. Why? Because when I will try to deploy my infrastructure, then the hash will be calculated, and Terraform will compare my calculated hash with the value which is on AWS. If this hash is the same, then new code will not be deployed because there are no changes. But otherwise, Terraform will try to deploy the Lambda function. I'm giving it the name, so routing, description. When it comes to handler, I would like to declare the entry point for this Lambda function to be the handler property from index file. Then I would like to basically publish the new version every time when I'm deploying to Lambda. I'm also assigning the role to this Lambda function, setting the runtime for Node.js, and also something about memory and timeout. Then I'm declaring the policy document, which basically assumes two roles. And then I'm declaring my IAM role. So I'm using this this IAM policy document, which I created here. I'm giving a description and name to this IAM role. Later, I'm creating the CloudWatch log group for storing the logs for this Lambda function. And I'm attaching the Lambda logging policy to my existing IAM role. So my Lambda function will be allowed to write to this CloudWatch log group. One thing which you may spot here is that I set the retention period for this log group to 14 days. But when I will go here into the log groups that are in Frankfurt, so in this replicated CloudWatch log group, I can see that the retention is set to never expire. Be careful with this, because this setting for setting the retention period will be taken into account only in the original region. So in this case, in North Virginia, but in those replicated log groups, it won't be taken into account. So you might end up with like huge bill from AWS. All right, so I have my AWS Lambda function defined. So it's time to define CloudFront distribution. I decided to extract to some local variables in order to avoid duplication. So I extracted allowed methods and cached methods into variables. Also, I prepared some variables for my backends. And then I'm declaring the CloudFront distribution. So the status is enabled. The price class is Europe, US, and Canada only. Then I'm going to use IPv6. No geo restrictions. I'm declaring some of my origins. So in this case, it's Heroku application. I'm giving it like meaningful name, which is from my local variable, and I'm defining the config for this origin. So the origin protocol policy is HTTPS only. So CloudFront will always ask this application using HTTPS. Yeah, similar config for other origins. And then I'm defining my cache behaviors. So when it comes to allowed methods, I'm using the one defined in the local variable. The same for cached methods. And I would like this caching behavior to take into account also those requests that starts from podcast. I'm using the podcast backend for serving those requests. I would like all the requests to be redirected to HTTPS, so basically the same which I presented previously in AWS console. I would like to forward all the query string parameters and cache based on all of them, so no white or black list here, no cookie forwarding, and I'm assigning to Lambda functions. So in this case, it's for the event origin request, and this is my newly created Lambda function, which the name is routing. And the last thing here is that I would like to use default CloudFront certificate. All right. So a little bit about how we use this stuff in Schibsted. Of course, you shouldn't expect the examples from like production code, but in most cases, it's like copy paste with limiting this a little bit in order to avoid having Lambda functions for 200 lines, etc., etc. But I think that you will get the feeling of what's going on. So first example, which I already covered, it might be used for simple routing. So if my path starts from podcast, then I'm rewriting URL and to get rid of this podcast in the beginning, and I'm fetching from the origin, and the same for the path which is starting from notifications. Rewrite URI to get rid of the notifications in the beginning, and then fetch from the origin. Another example might be simple WAF. So I can use Lambda to determine if this request looks suspicious, and if so, I can immediately return without even bothering my origin with this type of requests. If I will place it in the correct place, then also some stuff will be stored in CloudFront cache. I'm aware that AWS has like common WAF, but you might want to implement some of your features as well. So let's take a look into the code. I'm defining the next Lambda function here. All the code here looks basically the same as I show in this routing example. There are only some differences when it comes to identifiers. And the main difference, I would say, will be that I would like to pack my index.js file, which is in src lambda WAF directory. And of course, I'm giving the meaningful name and meaningful description to this Lambda function. All the other stuff is basically the same. Then in my CloudFront config, I would like to assign this or associate this Lambda function to my cache behaviors. So for example, I have my podcast path. So I would like to assign this Lambda function to the viewer request. So once I will deploy it, then basically it's there. So let's take a look into the code actually. So WAF and index.js. Again, I'm retrieving request object from the event, and I'm checking the query string. If it has code parameter in the query string, then I'm printing to the output that this request is blocked by WAF, and I'm printing the query string. And then I'm generating the response object with status 404 and body not found. Then I'm calling my callback with passing the argument this newly created object. And then CloudFront will find out that this is actually the response generated, and there is no need to pass the request to the origin. So let's test it. I have my path. So I'm asking this with code argument. As you can see, I'm getting not found. And if I will take a look into my response headers, I can see that again, I was served by Frankfurt point of presence. But in the Xcache header, I can see that this response was generated by Lambda. So there were no requests sent to my origin. It would be also great to see what is stored in the logs. So let's open the log group and log stream. And I can see here that, yeah, basically my WAF blocks the code request, and the query string was code equals to 1 to 3. And of course, some information from Lambda about duration and build duration and stuff like this. All right. The last example which I would like to show you is some sort of proxy authentication. So let's assume that my application or my CloudFront distribution has docs endpoint. And this should be somehow protected because I don't want to expose my API details to, to someone that shouldn't see them. But from the other side, I would like to allow people working from the office to access them without like additional authorization. Or if user adds like proper authorization header, he should be allowed as well. And this should be taken into account only for docs path. So all the other paths shouldn't be affected. So let's take a look into the code. I'm defining the next Lambda function, which is API docs. And again, this has basically the same code as it was in 2 previous examples. The only difference is that I'm basically deploying another JS file from another directory, and I'm giving like another name to this Lambda function. When it comes to CloudFront, I have my cache behavior, which will be taken into account only for paths that starts with docs. And for this path, I would like to associate my API docs Lambda function to the viewer request event. So let's check the source code. Yeah. So first, I defined the pool of IPs that is allowed to access my API documentation. And in the code itself, I'm retrieving the request object from the event. And I'm checking if user is not coming from the allowed IPs pool, and he didn't provide the authorization header, then I will log into CloudWatch that this client is not trusted or did not send the authorization header. Then I'm creating the response object with status 401 and body unauthorized, and I'm calling the callback with this response. Otherwise, if user either comes from allowed IP or provided authorization header, then I'm replacing the URL, just to get rid this docs from the beginning of the URL, and I'm logging this URL to CloudWatch as well. As you can see here, it's not like a good solution because I'm checking just for the authorization header existence. But I didn't want to mess it up with like checking if the value is allowed or not. So yeah, just check if the header is present or not. So let's test it. When I'm entering the docs path, then I'm getting 401. I can see right now that I'm served by another point of presence, which is in Munich, in Germany. And in Xcache, I can see that this is Lambda generated response. So let's take a look into the logs again. So I have like separate log group for this, and it's WAF, but API docs. Yeah. So I can see here that this client with this IP tried to access my docs, but is not trusted or did not send the authorization header. So let's basically provide the dummy authorization header. The value does not really matter here. So I sent the authorization header Yeah, you have it here, and I can see that I'm served with the response. If I will go into CloudWatch log, first I have to get rid of this authorization header, of course. Yeah. Then I can see a couple of the requests, that I was trying to request all the Swagger paths for the CSSs, JSs, etc., etc. All right. So you can find the code, basically in my GitHub, as I mentioned. Here you have the QR code for this. So yeah, feel free to scan. When it comes to other useful resources that might help you with learning what Lambda at Edge is, I strongly recommend to take a look into AWS samples organization on GitHub. There are like a lot of useful workshops, not only for Lambda at Edge, but also for different AWS services. So, and there is one for Lambda at Edge as well. So I strongly recommend to follow this if you would like to practice more when it comes to Lambda at Edge. Also, there is nice documentation provided by AWS with some sort of examples, some sort of practical code, which you are able basically to copy-paste into the Lambda console, associate with your CloudFront distribution, and then you are done. You can basically test it in the real world. One more thing which I forget to mention basically in when I reviewed this code. People often have the problem about how to test the stuff. So yeah, as with all the infrastructure things, I recommend to have like separate testing environment where you are deploying your stuff. And then you can write some sort of automated test, which will basically perform integration tests versus your infrastructure. But also, when it comes to this approach, you are able to test your Lambda. You can just do unit tests. So I decided to use Jest library for running the tests here. And as you can see, we have some tests for those Lambdas. So in case of WAF, I would like to create the event which has query string, which contains code equals to 1. And once I will call the Lambda, I expect to get the response, or I expect actually the callback to be called with the response object, with the status 404, etc. If my query string does not contain code, query param, then I expect this callback to be called with the request object. So thanks to this, you are able to basically run npm test on your Travis, Jenkins, whatever you use, and then make sure that your Lambda code is at least working when it comes to unit tests. So this is like additional guard for making sure that everything is running. Yep. So when it comes to this presentation, that's it. Thank you very much for attention. We have some questions. If I won't be able to answer all of them, and if you will have more, feel free to reach me out using my email address, or feel free to ping me on Twitter, and I will try to answer.
Filip, thank you for presentation. It was very good. And we have some questions. Are you ready for that? All right, great. So first question from Dominic. And Dominic asking you, how do you tune test Lambda edge functions before you will go live and make sure you won't hit any limits issues? Those testings which you showed us, or something else?
Yeah, that's actually very good questions. I don't have a good answer for this. So I would say you have to be reasonable or take reasonable approach. So, for example, if you have your Lambda function which is associated with viewer request, then you might think a little bit, maybe it is worth to move it to the origin request. So then you will get like cached responses from CloudFront, and your Lambda code will be called less frequently. But when it comes to like automated stuff, I don't have a good answer here.
All right, thanks. So another question from Oleg, and Oleg asks you, how does deployment of new versions of Lambda code look like in your case? Do you keep it run Terraform apply to create new versions of Lambda, or you use some CI tool to upload new zip with Lambda code? So,
Okay.
biologically or CI/CD stuff? How are you doing that?
Yeah, of course, CI/CD, because we are in 21st century and we should use CI/CD stuff. So in our case, it's Travis, and it's, yeah, depending on the project, it might look a bit different, but yeah, mostly it is Terraform apply, which is run on Travis.
All right, so Travis, okay, so Evgeny is asking the question, but I think that Travis is the reply for it, because he's asking Terraform could be run by CI tool. So we have Travis here in your case. So Marzena is asking, is there any limitation of send events? I see that she knows what she's asking for, because you smile a little bit. So this is going to be a tricky question. So thanks for that.
That's why I mentioned in the beginning of the presentation that I recently landed in DevOps position. The answer is, I don't know.
It's a very good answer, actually, because it's true. The worst is when you will start to say something. So, Marzena, I'm sorry, but we need to look into the documentation about that. So the next question is from Mateusz. Mateusz asking you, Filip, how about any common pitfalls and problems you face when you're working with Lambda at Edge? Anything from your company that you can share? From our company, so it's your colleague from work, you know, he's a guy, you know, he's like, he waited for that, you know, to ask you online for that, you know. I will do something for him afterwards. So Mateusz, thank you for the question. Filip?
Thank you, Mateusz, for challenging me in front of big audience.
Yeah, good one.
Yeah, when it comes to pitfalls and problems, I didn't face basically any of them right now. I would like to refer a bit to the answer which I gave to Dominic before. You have to be reasonable and you have to know what you are doing in order to avoid being overcharged for the CloudWatch logging and being overcharged for Lambda calls. But yeah, when it comes to interesting stories from our company, I'm not aware about them. So yeah.
No, it's many interesting story for sure, you know, but not in this case that Mateusz wished to be interesting, I'm sure. Yeah, good one. Mateusz, thanks for the question. Filip, I think that there is no more, you know. So thank you very much for the presentation. And guys, remember, so Anastasiya, if you can put on the screen the link to the pool, because we also have something from AWS user group. So we have some vouchers, and we'll send them on the end of the presentation. There is 3 vouchers of a couple dollars there. So still, if you want to test some Lambda functions, then you don't need to pay from your own pocket. Good stuff, because it's free. You know, this is the most important part. So Filip, thank you very much for the presentation. And thank you. One more thing. Tomasz, I like the last shot, you know, the last shot in the last moment. Tomasz, how do you handle the logs in the different location? So the last question for you, Filip.
Yeah, actually, when it comes to our company, it's fairly simple because we can stick to what CloudWatch offers. Our business is in Scandinavia. So we have basically all of our logs either in Stockholm or Frankfurt. So we can basically take a look into CloudWatch console, and that's it.
Yeah, Tomasz is expanding this question about that he meant a cost, you know, especially. So, you know, he pays, the company pays for that for sure, you know, or maybe, you know, credit or something.
Who cares?
But, who cares? You know, no, I'm just kidding, Filip. What you doing? Because there's never expired. You know, that sentence that you you know, that you mentioned during the presentation, I think is very important, because we don't want to have $100,000 bill monthly for keeping logs.
So in my repo, which was presented during this presentation, you have some examples of, I would say, bad choices. So with those, with logging like I have, you will end up with having like reasonable AWS bill. But if you will start, for example, logging whole request object or doing stuff like this, then you might end up with like huge troubles. And my recommendation here when it comes to the cost of logs is that, you should have like info or debug logs only if needed. If you know that something is weird, you would like to do some sort of debugging in production. And for the other cases, you should like limit the log amount to only the info that might be useful later on, because not always you are able to say when shit will hit the fan.
Yeah. Yes, thank you very much, Filip, for that. Okay, big applause. I'm sorry, but I cannot afford right now to do it.
You can do it.
Like, yeah, let's do it. Okay, perfect. Filip, thank you very much for the presentation. And right now, we have two people presenting. So, everybody, let's make a big shout for Ozan and Michał, and they will talk about serverless. Who expect that? So about the serverless again, today we will talk about how to test serverless. So I think that it's a good extension of this presentation of Filip, because we had some questions about testing. So let's talk about right now how to test the stuff. So let's welcome Ozan and Michał. And Filip, thank you very much.
Okay, hello everyone. Good to be here. Today, as we were introduced, we will talking about how we are testing our product inside AWS. So, how to test serverless. And before we start, let us do some introduction. So, I'm here with Ozan Berk. Ozan is my teammate. He works. He's passionate about automation process. He has more than 5 years experience in testing, and he's working for more than 1 year in AWS. And we are facing each day new challenges when it comes to testing in serverless.
Hi, I am Ozan. First of all, I would like to say it was a great presentation, Filip. Then let me introduce Michał. He's part-time student and he's part-time software developer in test. We work together 3, sometimes 4 days in a week. He has a AWS certificate. He's AWS certificated solution architect, and he has been working inside the AWS for more than 1 year. And and also he is the person who prepared this amazing presentation for you today.
Thank you.
Maybe we can, and also we will share this presentation together. It might be difficult to pass each other because I guess I don't know how to run remote presentation with 2 person. Sorry for that, and maybe we can continue.
Yes, perfect. So before we dive into the main topic, we would like to say something about our company. So we are working in Grand Parade, and the key information you need to know that we are the Grand Parade is a part of William Hill, and it's an international company which is focusing on providing gambling opportunities. So we are dealing each day with ton of data. Our responsible is mostly reaching to external providers, to external vendors. We are processing ton of data, and the most reason, the biggest key is here to have the testing is crucial part of this whole workflow. That's why we wanted to share with you our insight and tell how are we dealing with this ton of data.
Our agenda is for today. Why do we test inside the cloud? How we tested it? What were the challenges? How we solved? And what were expected outputs? And basically, we will talk about our journey, and then we will try to sum up all of things.
Yes, so let's start from our story. I think Ozan has prepared some wonderful story to share.
We would like to begin with one small story, which is our journey on AWS. I hope we won't annoy you, but like exactly 1 year ago, we chose AWS as our cloud provider, and as a result of this decision, we needed to we built a couple of like new products, new applications, and we needed to deploy those products on AWS. And there was an issue because I and Michał had no idea about what, like, we had very limited, very small knowledge about the AWS. We weren't aware of the components which we are going to talk about right now. Like, we didn't know what is SNS, what is SQS, or what is step functions, or why do we need them. And also, we were going to be first two person in the company that is trying to test something on AWS. Like, there wasn't too many people inside our company to reach them to get some help. Basically, we just spent all our day in AWS Java SDK. We read almost all SDK, like all AWS SDK. We spent too many times on Cloud Guru to understand what are the components which we are going to work and why we need them, and how we can test those components. And the solution actually was good. Like, we were slowly and constantly improved our knowledge. And today, I guess 1 year later, like exactly 1 year later, we found a chance to talk here about our presentation, about what we have done. And thank you all of you for listening us from now. Like, we built a couple of different products. Our main target was to build something reusable and flexible for like to populate in our company. And I guess we will talk about that now.
That was a great story, Ozan. Thank you. So let me say something about our goals and expectations. As Ozan mentioned, we had whole year to build our testing environment, our product. So we wanted to have some bullet points. We wanted to create an environment that is unique each time you run the test. Because previously in our company, we were having on-premise services, and there was one static shared environment, testing environment. And you know how the problem is in big companies with shared testing environments. Sometimes there's too many people working on it. There's too many data. It's unstable. There may be problems with data consistency. There may be some deployment of wrong jar or product, and it blocks the other teams. So we didn't want it to mirror the same problems, same issues. And because we were introduced to AWS, which is the world where everything can highly scale. So we wanted to have a unique environment for each test run. So that was our first key point. Then we wanted to have a data consistency between the tests. We wanted to find a way somehow to inject the data into our environments. Then we want to have a highly scalable solution, which can be fast, and we wanted to have a quick access to the results. And at the end, we wanted to implement this whole strategy into the continuous delivery. So our testing environment can be automated, and it will be part of each deploy of basically each Git commit. It will just spin out our environment, and the tests are being run inside of it. So that was our goals and expectations for our testing journey in AWS. And let me start simply of overview of infrastructure. This is example infrastructure of our product. You need to know that our products are mostly event-driven. That's why on the picture here on the diagram you can see lots of lambdas. On the left side we have some on-premise servers. There's some Kafka topic that our AWS product is reading from. We have some selector on the top left. This is a Lambda that fetch data from the Kafka topic. It's being triggered by a CloudWatch rule, specific number of times in a day. The data that is being grabbed from the Kafka is being pushed to the SQS, which triggers the second Lambda connector. There's an API gateway in the top. Connector talks with the real internet, with our real providers, with external companies. We are fetching some data. We are storing it in DynamoDB. We are storing them in S3 bucket. We are processing them to the second SQS, and there's a transformer Lambda. This is where the data is being transformed, mapped based on different business cases. And at the end, we are sending the data back to the MSK cluster in the AWS from other products in company, other internal components can read from. So this is the example of infrastructure that we will now explain how our testing process looks like. It's not very complicated. As you can see, the data starts on the left side. In the middle, we are talking with internet, and at the bottom, we are transforming the data and storing them and passing them later to the lower components. So it's pretty easy, and now we will design our testing environment for it.
We will talk about 6 different challenges today. Like we combined and we put 6 different challenges for our presentation. And the first one is creating unique environments. I guess if there is QAs in this session, probably they are aware, but I believe everyone is aware problem of using stable QA environments. Michał has already mentioned about that. Like we are a data company. Like we produce tons of data. We have too many products which collects too many data from our feed providers, like from different third-party companies. And also everyone in the company, in our team, basically, especially QAs, our business analysts, product owners, devs, like everyone is producing a data for the QA environment to test something they want to test. This is expected behavior actually. But this will cause tons of data on the QA, and some of them even broken. Why it is broken? Because like some of the apps we have no idea what they expect as an input. We are, for example, looking from logs, and we are producing that JSON into QA environment, but that might be broken, or that might be just broken as a result of all this process. At the end, we can, like in the QA, there are too many data, which most of them may be broken, and this will always affect our test execution time. Like for example, we can see, like we were seeing the results sometimes in 10 minutes, sometimes 30 minutes. Like there wasn't any consistency about the time. But our target or our like we wanted to see the results all the time in the same amount of duration or same amount of time. This was important to see that our tests will be always finished same amount of time or at least approximately. This was the problem using stable QA environments. We wanted to go with unique environments, and we use Terraform to solve this issue. Like Filip actually, we also use we are also using Terraform to provision to create our AWS resources. And thanks to our solution, thanks to our development team, everything is Terraform. Like every products, every applications are Terraform driven. Like what does it mean? We can just simply overwrite the environment variables for our QA environments, and our products, our lambdas, or our lambdas will be able to get those environment variables, and it will run against those components. And what we have done is we mirror our infrastructure from our end-to-end test project. Like we have a one repository to store all the infrastructure code. This is our cloud engineer is dealing with this repository, but also everyone in the team is always like pushing commits or creating resources if it is needed. And what we have done is we just pointed that repository from our end-to-end repository. Basically, we have introduced Terraform to our end-to-end test project, and as a result of that, we were able to create the resources which we will need to run our tests. Like this is our pipeline, for example. This is like as soon as we push our codes, our commits, it will be builded, and if the build is green, then Terraform apply will be triggered, and it will create the resources which we will need. Then our tests will be run. And yeah, this is for example, this in the left side, you can see the environment which we are going to create, but we also wanted to have unique environment per every commit, and we solved this one. Like there is a picture in the right corner. When we push our codes, or when we push something to our GitLab, basically we use QA prefix, and we got the commit ID from GitLab, and we just combine them and pass to Terraform. And Terraform, basically Terraform will create a new environment using QA plus the commit ID. As a result of this, we were able to create hundreds of different environments, and we were able to run tests in the same time with Michał, but we weren't going to affect us, because basically he will have his own environment and I will run my test inside my own environment. And this is actually how we solve our number one challenge. We use Terraform, and we just created all the resources we need.
And the challenge two, which is how to interact with created services. As Ozan said previously, now we have unique environments each time we send something to Git. And now we want to have a way to talk with this environment. And we found out there are two main approaches. We can run our test suite in a Lambda function, and we can run them from the GitLab runner. And this is not by accident. These two bullets are not here by accident, because we go through these steps in the beginning of our working with testing in AWS. The first bullet point took us like 6 months. Then we realized that maybe it wasn't the best solution. And so we switched to running tests from GitLab. So the previous screenshot with the automated pipeline was directly grabbed from the solution number 2. But let me just go through the first solution as well, because it has some advantages and disadvantages as well. So what we mean by running as Lambda is we created this jar with a Java jar, which has all the necessary SDK to talk with, necessary clients to talk with AWS resources like DynamoDB, SQSs, buckets, Postgres, DynamoDB as well, some different components, some API gateways. So we have created this testing jar which has access to these different clients, and then it executes the test by talking to them, checking the data, to compare each checkpoint in the data workflow. So that was pretty easy to do with Lambda, because Lambda has all the necessary credentials out of the box. It's super easy to add some security groups, set up some policies to the Lambda. So on the one side, this is super easy to create, and easy to run. That's why we started with this solution. But on the other side, Lambda is not the perfect option here, because Lambda is not designed to run for 10 minutes. It needs to be quick and needs to be fast. So we started searching for some second solution. And this is when we start working with GitLab. Because when our company moved to AWS, the runners of the GitLab was stored inside EKS in AWS as well. So the credentials needed to talk with AWS services were there from the beginning. We just needed to extract them. So that wasn't a big challenge. We just simply change our credential beans. We just do some Java code improvements, and we were able to talk with the resources from the GitLab itself. So that was super easy. The second thing that was also out of the box was results from the test. Because the tests were running in a pipeline, we were able to see each logs in a GitLab directly. And then the results from the test being run also was out of the box for us. We get this information about the test passed or not instantly, and we can combine this into our automated CI/CD deployment. Basically, the test run, okay, you can possibly deploy to prod. The test failed. We're not giving you this up. Okay, I've had some network difficulties, but I'm back. Ozan, where I finished?
You are saying, okay, I also lost because I was thinking what happened to you.
Okay, don't worry. So let me summarize. GitLab was perfect fit for us. We have quick access to the test results. We have out of the box credentials because our runner was stored in the EKS, and it was super easy to put this testing in our automated CI/CD. So basically, this is our current solution. We are having the stage that puts jar into the GitLab runner and talks with necessary AWS components. So we definitely think running it from GitLab runner fits the testing much better than our first solution, which was running from Lambda. Okay,
the challenge today is about data consistency between test runs. Actually, we kind of solve this issue when we go with like unique environment per test execution. But there was still some issues regarding the data consistency. Like, can you change the slides? Okay, like for example, this Kafka topic is our entry point to our AWS world. And inside our test, we use test Lambda for this presentation, but it doesn't matter. Like, it is basically the same. Like, you can use Lambda or you can just run from GitLab directly. We did both of them. But basically what we did is producing data to Kafka. And that was easy because we just needed the Kafka client, and as soon as we implemented that client, we were able to push our data into Kafka topic. But the issue was to get those data inside to our AWS world. And in here we have a subscriber Lambda, which will be triggered by step function, and that step function basically listens CloudWatch cron like trigger. And we open AWS Java SDK there, and we just read the step function client. We implemented that client, and we were able to talk with step function client from our test code. As soon as we push the data to Kafka topic, we went to step function, we triggered that one, and then subscriber Lambda, like our first Lambda, will start consuming the data, and when it will find the data, it will grab it and push into our AWS world. This was easy, but the real problem actually, like we need to get response for the data which we produce, because inside this solution we need to talk with our feed provider. But we didn't want to talk with our feed provider from QA environment, because like our feed provider might be down, or it might like the response, finding specific response might be risky. That's why we thought we came with another solution, which is in the next slide. Like we needed to talk with our feed provider, and we didn't want to talk from QA. What we have done is we used AWS API gateway, and instead of our feed provider, we just overwrite this our connector environment variable. Like inside the connector environment variable, Terraform was putting our feed provider's URL there. But we just overwrite that URL with our API gateway one. Now connector was able to talk with our API gateway, but there was, of course, one small issue. No one, like basically, there is nothing on there is nothing after the API gateway. We just built some small Lambda function. And we put some small Java code that returns the response against the data which we produce. We put some JSONs there. Like basically, when the connector grabs the data which we produce, it will talk with the API gateway instead of our feed provider. Then mock Lambda will return the response for our data. Then connector will grab the response into our AWS world again. Then we were ready to run our tests against the environment which we created.
And that brings us to the next challenge, which is creating a test suite. So check this example here. We have our entry point on the left side and our ending point on the right side. So the biggest end-to-end you can imagine is producing data to the first Kafka. It triggers the whole workflow because our architecture is event-driven. So at the end, when we wait some couple of minutes, the data should be available on the right side. But it creates a massive end-to-end test that you have no idea what's happening after this endpoints, after this Kafka topics. So we didn't want to introduce that kind of test. We wanted to go with much more integrational test over the end-to-end. So we know that after the first Kafka, there's a Postgres DynamoDB. So we wanted to use this resource as our checkpoint in the data flow. So we know how subscribers should work because our developers design it. So we are now checking if it produces the correct data. So we are testing against the Postgres, but it don't have to be a Postgres. We have much more options to choose from. We can choose DynamoDBs, we can choose S3 buckets, we can test even in the last Kafka topic. And we don't always have to produce the data in the first stage. We can produce the data to the SQS on the top of the diagram or to any of the SQSs in a workflow later. So we have this ability to create integration or many integration tests, and we are using this AWS resources as our checkpoint. So we are seeing if the data is being processed correctly, and it gives us much more better view of what's happening in our flow and which components may not work properly. And we're not only testing the positive scenario, we have this possibility to put the wrong data, to put some wrong JSONs, to see how the resources will behave separately or together. So we have total control of our environment because this is our sandbox. So we have this possibility to do anything with it, and because we have clients configured to each module, to each resource, we can basically use it, poke it as much as possible to see if the resources are working together properly. So this is how we design our test suites. We are producing different data. We are checking each stage in our workflow, and also we have this possibility to not only test positive tests, but also this failure scenario, because when the Lambda fails, the message is being put to dead letter queue. So you have this also possibility to see if the Lambda fails. So this is like the expected failures. And we even started to do something with Ozan in our current project when we are testing some scenario, for example, testing if some alerts being triggered. We, for example, destroy one Lambda, and we are seeing if specific alerts are being triggered. So we have this possibility to monitor our alerts as well, and I think that's actually pretty cool. Ozan, would you like to add something to this stage?
Yeah, just one small update. Other than the alerts, we have also a couple of tests, which is like we are just deleting, for example, entire Dynamo. Like we are deleting the Dynamo table, like removing the table from our flow. Then we are putting the data again to SKS, and we are testing that Dynamo table will be created again. Like we have also test cases for this kind of stuff, not like producing the wrong JSON or wrong data. We also remove some of the components, then it should be automatically created. We have also tests for this, thanks to this solution. And the challenge number 5, which was continuous delivery. Like we wanted to reach, like we wanted to deliver our product to production without touching anything, like without any manual interaction. For this is a pipeline from one of the from our product, our source code repository. Like after our development team is done with their changes, they are creating MR, and as a result of that MR, the code will be merged to master, and firstly build and integration test will be unit test. Inside this build, actually, there is also unit tests, like unit tests and build will be run. If that is okay, it will push to a new version of jar to S3 buckets, like for dev, for non-prod, and for prod. Like it will, our new version of jar will be automatically uploaded to S3. And in the last stage, there is a prod create merge request, which is this stage basically will create a merge request in our infrastructure pipeline, saying that this is the new version of jar. You need to build all infrastructure from scratch, and you need to update the version of this Lambda. And this is something we achieve with our cloud engineer, with our deployment team and our dev lead. But the most important part actually in this part, like basically in this state plan and dev apply, like Terraform plan will be run, and then dev apply will go and update the Lambda function with the one which that got from the source repository. And this is something we can skip for now. The most important point, it will also trigger our test pipeline, and it will say that this is the new version of Lambda. Could you please run your test against this version of the Lambda? And this is basically our pipeline. We have 2 builds, which like one is for our intent test, and the second one we already described. We have one more Lambda or one more product, which we store our response, and we call it mock Lambda. Then this Terraform apply will be triggered. It will create environment with using K and the commit ID. As soon as this will be passed, okay, we have two stage, which is enhancement plan and enhancement apply. This is not relevant for today's presentation, but we have also applications that runs inside the container, and we are also testing those kind of products. But this is our common test framework. That's why they are here, but they are not relevant with this like today's talk. As soon as Terraform apply is done, basically we will be able to run all our tests against the environment which is created like a couple of minutes ago, and the new version of jar will be like is deployed already. And then we have this storage stage for Huntsman and for Terraform, because we create new environment per execution. But sometimes we just disable this storage stages because we want to test something and we want to see, like we are just logging into AWS, we are checking some of the things, we are doing some manual tests, or we are doing some experimental sessions, and sometimes we forget to rerun the storage stage, and that brings us to challenge 6, I guess.
Yes, which is tearing down used services, used environments.
Which is a challenge we introduced, actually.
Yes.
This wasn't the challenge.
We all work with AWS, and we know sometimes the billings can be high and expensive. So we wanted to provide some solutions, some backup option for us. For example, if we forgot to run the destroy stage. So we designed some Lambda that's being run each midnight, scans through all our environments that are tagged with QA tag, and basically we are deleting each resource each night. So this is the diagram of our costs before and after we introduce this Lambda to destroy used services. So you can see easily that we introduced this service to tear down used environments in the middle of the diagram. This is where our costs slow down from high to low. So right now, each midnight, if we left some QA environments open and running, we don't have to worry, because each midnight we have a Lambda that's being triggered and destroy our QA services, QA environments. So the next day we go back to work, we have clean AWS account, and no one is going to have any doubts that something is running by accident. And that was our last challenge, that we learned it hard way, because we introduced the problem, so we needed to solve it somehow, and the Lambda that clears everything was the solution we designed. And at the end, we think that there's still some fields to improve our testing solution, but this is what we decided to share with you, and this is how we are running our tests against the products that is designed in our teams. So I think this is part for some Q&A section.
Okay, thank you guys. Good presentation. We don't have many questions, but we still do have one question, which is kind of tricky one. Evgeny asking, do you test your Terraform code?
Basically, there are two schools of thought. One of, you can test it or you don't have to. We are testing it because we are creating unique environments. So in order to create an environment, we need to have a working Terraform code. So without working Terraform code, we're not going to have a created environment. And if the environment is going to fail for some reason, we get the information in our GitLab CI pipeline, and it will automatically hit the message, oh my God, your test failed, your environment is failing. And at the end, it also ran the Terraform destroy section. So even though I did not create the whole environment successfully, we are taking care of clearing everything after. So I think, yes, we do test our Terraform code, but is it needed in our case? Because the way we designed it, of course it's needed. So it's like additional feature we introduced.
Okay, so you actually reply for another question that popped up from Evgeny, which is why not using Terraform destroy to remove your QA environments at the end of the day? So basically, you are doing that on the end of the day.
Yeah, we are using Terraform destroy, but when we disable that stage to test something manually, we can just go and like retrigger that destroy stage, but it doesn't work all the time. And also, we don't know how many environments we create, and we don't know the prefix of the environments which we have created. That's why we can't just run Terraform destroy, because we don't know which environment is right now running on the QA. That's why instead of going with that approach, we just implemented one more Lambda, which just terminates everything basically.
Okay, so basically you're using that, but in different scenarios.
I think like because we are humans, we are sometimes lazy. We forgot to run Terraform destroy at the end of the day, and we did it like a couple days in a row. We just forget to do Terraform destroy, and at the end of the week we saw that we are reaching our AWS limits for that account, and we wanted to find some solution that will do it for us, because we love automated process. So we created a small Lambda that is being run each midnight, so we don't have to take care about anything right now.
Right, thank you. Thank you very much. So we have another question from my my ability to read that alphabet. It's a little bit rusty, so sorry for that. I think Svetlana, I think like this. So thank you guys for this wonderful presentation. A lot of useful information. How much time do you spend to identify the best practice for testing your AWS solution? So what is the trade-off? If it was worth, it was a lot of time. How are you doing that, man? So you're taking the solution, and when you look at this, how much effort do you have to prepare the testing?
Okay,
I will pass it to Ozan.
That is tough one. How much time we spend to identify the best practice for testing our AWS solution? Like I don't know. Like when we need to, but like when we see the solution definition, or when we learn to what we need to do, or what are the components which we need to test. I guess this is I guess I don't know how to answer this question. Like basically we just need to some documentation or some solution to see, to identify the test scenarios. But
so maybe let's go a little bit around this question. So when you design those testing and when you implement them, did you do it like the organic way? So you did all by yourself, or you take the experience from some web pages, some best practice guides, some courses? How you did it? Do you invent it, or you just take the experience from somebody?
I guess we invented this solution, not with Michał, with our team, with our deal lead, and with our every developer inside that team. Like basically we changed our solution every single day for maybe 1 month, because we didn't know. Yes.
Sorry. So basically, you didn't find any like reliable source for information, like how to test that. Like a step-by-step guide. How you should do it.
Yeah, that wasn't because like the real issue, we weren't able to talk with our QA components from our local machines because of some security concerns, and we didn't disable any security. That's why we first built Lambda function to run our tests. Then 6 months later, we realized that we can do this one using GitLab Runner, because 6 months later there's a chance to run our tests inside the GitLab because those runners deploy to AWS. Like this is like we learned every single day, and basically.
So we're like a super agile guys. Like every day something new on top of the stuff that it's already there.
Like basically this challenge 6. Like for example, we didn't know that we are introducing a problem, but at the end of after 2 weeks later, some guy told us that, what are you doing, guys? Like there are hundreds of QA environments which is created by you. Why you are not destroying those environments? Then challenge 6 came. Like this is how we identify best practice, and I don't think we just reached that.
Okay, so thank you very much for the answer. And another question from Krzysztof. Krzysztof asking, how long does it take to build entire environment, like you showed on example?
I can take it, Ozan.
Of course.
Okay, so basically it depends how huge environment you have. For us, in our product, on daily basis, we have like few Lambdas and DynamoDB, a few buckets, SQSs, and to run the whole Terraform apply, it's just less than 2 minutes. But in a previous product, we have a Postgres DynamoDB, which was Postgres database, which was huge. And to create a Postgres, we needed to wait like 8 minutes per each Terraform apply. So we decided to move this Postgres into a shared repository, to completely shared environment, shared as a shared resource, and all our QA environments were basically talking with the same Postgres database. This is only to cut this 8 minutes, which is too long to create only one database. I don't know why AWS take. Okay, we know why. This is because the way it's been initialized, but let's not talk about it right now. But yeah, so it's less than 2 minutes right now to create a unique environment.
Yeah, and maybe one small update to this question. Yeah, 2 minutes to create environment, like 1 minute to build our Java code at the mock Lambda, and basically in 20 minutes we are able to run 30-40 tests.
Okay, right. So basically, up to 3 to 5 minutes, you have everything up and running in the worst case scenario.
Yes.
Yes, and maybe it's a good opportunity to say how we are, because we have also possibility to run tests locally. We have implemented our Okta profile, so we are getting all the credentials necessary, so we can run the test locally. We just need to have an environment. So sometimes we're just spinning an environment and we are running all the tests from our local computers, and at the end of the day, we're just pushing the code to make sure that it will work in the same way. So sometimes we are just working with one environment for the whole day because we have access and possibility to talk with it. So the time that it takes to build the whole environment, it's minimal. It's not even a problem for any of us.
Okay, great. Thank you very much, Krzysztof, for the question. And another question from Marzena. Have you got test strategy and test plans? Have the devs help you in this solution?
Yes.
Yes, for all, for everything, or just first one?
The second part.
Okay, so the devs help you.
Yeah, starting from the first day, everyone had all our devs helped us, because everyone was in the dealing with AWS in it was really new for all of us. Like basically we didn't know too much things. We learned together. Then all our team got AWS solution certification. We just study a lot, and we implemented all the clients, all the AWS clients with our dev team. Yeah, they had a lot about test strategy and test plans. We got our test plans prepared by our business analyst, and we have a test strategy which was built with Michał and me. We just knew what we should do. That is I guess.
Mm-hmm. So, but basically, what you said before, so the solution was developing by itself in time, and I assume that the strategy and test plans was going the same direction. So basically, the product was in this stage of work, and you had that kind of testing and strategy, and after that, it evolves, or you just, magically build everything, and after that, oh my God, forget testing, and build the testing. How it was going, because both scenarios are pretty realistic,
Yes, in the same time, but yes, maybe we can continue.
I remember that we had some at the beginning, when the developers started doing the work with the products, with the Lambdas, we started in the same time the testing approach, right? So there was some time when we were behind them, like a lot of behind, like 2 sprints behind them. So the developers started to helping us. We are combining our work. We are doing like T-shaped team formation. So we wanted to make it possible because we wanted to have a part of continuous delivery, right? So now we are ahead of the developers. We have an environment, we have everything prepared, and we see that there's something new that needs to be added to our product. We have everything basically ready, so we are ahead of them, and we are ready to prepare tests before they finish implementing solution.
Okay, the question from me right now. So do you help devs right now?
Oh, of course.
Good boys. The payoff. Yeah, good. Very nice. Great. Thank you very much. This was the last question. And thank you very much, guys, for the presentation. And yeah, we will wrap up, I think, right now. So, Anastasiya, I think you should join me a little bit here. So, first of all, thank you very much for having us today, for amazingly tasty pizza there. And we have the last thing to tell you, to share with you guys. We have 3 winners of our lottery of coupons for AWS. We'll contact you via email. So if you have it ready, Anastasiya, could you put it on the screen? So because in the end, it's kind of nicknames, so I will not try to read them, okay? So if you will find yourself there, that means that you will get something from us.
Yeah, so the winners are...
Yeah, and the winners are, yep. Okay, so that's the guys. Try to read it, okay? If you know yourself, you can do it. But thank you very much for participation. And remember that AWS User Group is created both by our partners, like Schibsted today, and also by you guys. So you users and the people who use the AWS. So if you have a good story, if you have a story about technology that you want to share with us, just find me on Twitter. Go for the meetup, contact with us, and we'll make place for you here to present something. It not need to be 45 minutes. It can be a 5 or 15 minutes, and just present something that you think that will help somebody. Like today, guys from Schibsted, the Filip from Schibsted. It was amazing presentation. Ozan and Michał also. So thank you very much, everybody, and thank you, Anastasiya, for helping arranging that.
Yeah. Thank you for joining.
Thanks. Have a great evening.
Bye.
Bye-bye.